In our second video on inequalities, what we're going to be going through is how to solve inequality equations. So this looks very similar to solving normal algebraic equations. However, the difference here is what you do and what to look out for when you've got inequality sign instead of an equal sign. Now, the key thing to know about solving inequality equations is that these are solved in the exact same way as when you are solving equations if you had an equal sign instead of an inequality sign. So what I mean is that this question for question 1 is solved in a very similar way as if the inequality was replaced with an equals. With question 2, it's like me solving this equation, and for question 3, it's like me solving x plus 7 equals minus 23. Now, if you're able to answer these types of questions or solve the equations, then this is going to be an absolute doddle. So the key thing to remember here is that the inequality sign needs to be stayed fixed. Although how we answer these questions are very similar, you've got to make sure that they are a completely different topic and that the inequality sign needs to be present in your final answer. So for question 1, what we need to try and do, now when we're solving an equation, our main objective or what our end game is going to be is to get x equals, or x is less than or more than or less or equal to or more equal to. That's what your final answer should look like. So your aim is to try and get x by itself. So looking at question 1, what's on the same side as x, what I need to get rid of is the 4. So I ask myself, what is the 4 doing to x? Well, it's timesing. So to get rid of it, I need to divide by 4. So now I'm going to have x by itself. The inequality stays in the same direction, and then I've just got to do 24 divided by 4, which is 6, and that there is my final answer. For question 2, again, I need to get rid of this minus 6. So how do I get rid of minus 6? Well, I add 6, so I'm going to end up with x is greater or more or equal to, and it's going to be 13 plus 6, which is 19. And then with question 3, again, how do I get rid of plus 7, sorry? I take away 7, so here I'm going to end up with x is more than, and it's minus 23 minus another 7, which is minus 30, and there is your final answer. So moving on to slightly more complicated questions, let's have a look. So here what we've got is a set of questions. Now these are what we call two-step equations. So looking at question 4, I need to get rid of the minus 4 and I need to get rid of the 3. So when we're solving equations, we do the reverse of BIDMAS, so we get rid of whatever's being added or subtracted first. So I'm going to get rid of this minus 4 by adding 4. So what I've got left on this side is the 3x because I've done nothing with that. And 10 plus 4 is 14. Then to get rid of the 3, well, what's the 3 doing to x? It's timesing, so the opposite is to divide. Now at this stage, you may be tempted to reach your calculator because you're thinking, well, 3 doesn't go into 7 to 14. But I would always recommend that if you can't work it out, leave it as a fraction. So the final answer is just going to be 14 over 3. Now if you wanted to write it as a mixed number, that's entirely up to you. So how many 3's go into 14? That would be 4, remainder 2 and 2/3. So it would be 4 and 2/3 again if you want to write it. But again, either of those two answers would be absolutely fine. Moving on to question 5. So again, what I'm doing here is to get rid of the plus 8. I do that by taking away 8, so I end up with 5x is greater or equal to 12 take away 8, which is 4. And then again, I'm going to divide by 5. Does 5 go into 4? No, it doesn't. So what I'm going to do is I just leave it as a fraction. And it's always important when you're dealing with algebra, is if you do end up with a number you can't work out, or when you're dividing, just leave it as a fraction. Never write it as a decimal, and God forbid, do not write it as a decimal either, as a rounded decimal. So for question 6, again what I need to do here is expand the brackets first. So if I do 3 times x, which is 3x, 3 times minus 4, which is minus 12, and as you can see by doing one simple thing, it turns up very similar to what I've done in question 4 and 5. So the next thing I then need to do is add 12. So I've got 3x is less or equal to 38 plus 12, which is 50, and then I'm going to divide by 3. So x is less or equal to 50 over 3, and there is my final answer. And again, if you want to write this as a mixed number, that is entirely up to you. So moving on to our next set of examples. So here we've got double-sided equations. Now the general rule of thumb when you've got double-sided equations is always get rid of the smallest amount of x from both sides first. So here I've got 3x is the smallest amount of x. So I'm going to take away 3x from both sides. So if I take away 3x from the left hand side, I end up with 5x minus 5 is less or equal to, well, the 3x cancels with the 3x, so all I'm left with is positive 5. Then, so it turns very, very similar to what we've done with the previous examples. I'm going to add 5, so I've got 5x is less or equal to 10, and then I'm going to divide by 5, so x is less or equal to 2. And then for question 8, so I've got brackets on both sides, so if I expand both set of brackets, I end up with 9x plus 3 is greater than 4x minus 12. So again, here I'll get rid of the smallest x, so I'm going to get rid of 4x from both sides. So if I just write down what I'm doing, I end up with 5x plus 3 is greater than minus 12. And again, try not to forget or lose any signs, just be wary of that. And then we've got to take away the 3, so I end up with 5x is greater than minus 15, and then divide by 5, so I end up with x is greater than minus 3, and there's your final answer there. Then leading on to our last two examples, which just involve fractions. Now when it deals with fractions, what you want to try and do is just do the layers. So when it comes to this, you've got to ask yourself, what do I get rid of first? Do I get rid of the 2? Do I get rid of the 3? Or do I get rid of the 4? Because I want to try and get x by itself. Now with this, we always, like I said, we end up doing reverse of BIDMAS. So I'm going to get rid of the 4 first, and I take that to the other side. So you always want to get rid of the denominator, which should always be your plan, because what's better than an equation that's got fractions is an equation without fractions. So get rid of the denominator first. So here what we end up with is 3x plus 2. And to get rid of that 4, it turns to a times by 4. So then minus 10 times 4 is minus 40. Then I'm going to get rid of the 2 by taking away 2. So I've got 3x is less than minus 42. And then x is less than minus 42 over 3, which is going to be the 14. So it's going to be minus 14, and there is your final answer. And then finally for question 10, again, we're going to get rid of the denominator. Now with this, what I'll probably recommend that you do is you put brackets around the right hand side. So we're going to times the whole thing on the right hand side by 3. And so what we get is we get 4 2x minus 3 is greater or equal to 3 lots of x plus 2, because not only do we need to multiply, as we've got two things on the right hand side, I need to multiply both the two things by 3. So what I end up with is 4 2x minus 3 is greater or equal to, and it's going to be 3x plus 6. Now if you multiplied the two things by 3, then you probably wouldn't have needed this line here. You would have gone straight onto this line that we've moved on to here. So from this we expand the brackets, so we've got 8x minus 12 is greater or equal to 3x plus 6. Again, we get rid of the smallest amount of x, which is the 3. So if I take away 3x from both sides, I end up with 5x minus 12 is greater or equal to 6. Take the 12 over to the sides by adding 12. So I've got 5x is more or equal to 18. Take the 5 over by dividing, and because I can't work out what 18 divided by 5 is, my final answer will simply be 18 over 5. And again, it's entirely up to you whether you want to write that as a mixed number, and you go from there. Now you can always check your answers by substituting numbers in. Obviously a little bit difficult when you've got inequality signs, but generally speaking it should equal 0 if you've got it correct, or should equal the number that's on the right hand side. Hopefully this makes a little bit of sense, and hopefully you can see a lot of connections between solving normal equations where it involves an equal sign and how you can relate it to when you've got an inequality sign. Worst case scenario, if you do get stuck with solving an inequality equations, is simply think to yourself, what would I do if there was no inequality sign, it was just an equal sign? And that should be the steps they're going through. Now there is something that you do need to be wary of when you end up with negative x's. So what I'm going to do is just do an example of what you should get is if you do get a negative x. Now with negative x's, now what I mean by, if I just write down some negative x's. So for example, if I had 10 minus x is greater or equal to, let's say, 6. Now there's a general rule of inequalities that whenever you are multiplying or dividing by an inequality, when you've got inequalities, you need to reverse the inequality sign. So if when I'm going through my steps of solving an equation, if you ever find yourself either divided by a negative number or multiplying by a negative number, there is a rule that states you have to reverse the direction of the inequality sign. Now for me personally, there is a way around this. Now whenever you have a negative x, which in this case we have here, what you want to do is take it to the side to make it positive. So if I take that x over to the side, and whenever I take it to the side I've got to do the opposite, then what I end up with is 10 is greater or equal to 6 plus x. Or, how I could write this in another way, is that x is more or equal to x plus 6. And now what I'm doing is, now in the previous examples we always had x on this side. Now what we've got is x on the right hand side, and all I need to do is just simply take the 6 over to this side by taking away. So 10 take away 6 is 4, and the inequality stays the same. So as you can see, all we've got here is that out of the two, which one is smaller, or x is smaller. And again, you can leave your answer just like that, or if you really want to be swapping the things that are on either side. So if I swap the x and the 4 the other way around, I've got to reverse the inequality. So looking at this here, the x is smaller, and the inequality is pointing at the x. So if I rewrite it, the inequality has to be pointing at the same thing. Now these two things that I've written down are exactly the same. It's just another way of saying this. So if I was to read this, so just call it #1, that says that 4 is bigger or equal to x. And if I read this one, which I'm just going to call #2, it's saying that x is less or equal to 4. So both mean exactly the same thing, but just another way of reading and writing it. And so again, whenever you have a negative x, your revision guides and websites and other teachers might say differently. Me personally, I always think make the x's positive, and then you don't need to faff about with changing the directions of the inequality if that is due to happen. So hopefully this makes a little bit of sense, and if it doesn't, feel free to drop me an email, or if you'd like an accompanying worksheet that covers all the topics that we've done in inequalities, then again email me at 162maths@gmail.com.